Okay, so this was kind of titled, it's L36, but it was titled Fundamental Theorem of Algebra. So what we're going to do basically is talk about what we'd done before was I gave you the function and you found all the roots. So what you're going to be doing now is, given the roots, can you find the function? So something to remember is that if you were to solve an equation like x squared minus 7 equals 0, you would add the 7 over and take the square root. And when you take the square root, there are always two solutions, the plus and the minus, which means they're conjugate pairs. They have to come in pairs. Just like if you were to solve x squared plus 7, it would be x squared equals negative 7. So x equals plus and minus the square root of 7i. So irrationals with square roots and imaginary with the imaginary I always come in conjugate pairs. So if I were to tell you that a function had the roots 5, 2 plus I, and the square root of 3, then it has to have also the conjugate pair to 2 plus I, which is 2 minus I, and the conjugate pair to the square root of 3, which is the negative square root of 3. Okay? Now, it says, given the following list of roots, determine if there are any more roots than there are, and the degree of the function. So the degree corresponds to the number of roots you have, and since we have 1, 2, 3, 4, 5, we would say that the degree is 5. Okay? On this problem, I'm telling you that their roots are negative 5/3, 7 minus 6i, 4 minus the square root of 2, and negative I. Well, this one, since it's 7 minus 6i, it also has 7 plus 6i. So if that's present, so is that one. 4 minus the square root of 2 means 4 plus the square root of 2 is there. And negative I means positive I is there. Negative 5/3 is a real root. It's not irrational or imaginary, so it does not have a conjugate pair, which means we have 1, 2, 3, 4, 5, 6, 7. 7 is the degree, because there's 7 roots. Fundamental theorem of algebra says the number of roots is equivalent to the degree of the polynomial. Okay, so for the rest of the lesson, what I did is I took everyone through finding the function given the roots. So if you've got 3 minus 2i, well, then what we do is first you need to be able to write it in factored form. So if I were to tell you that the roots were negative 2 and a positive, let's go with positive 2 and a negative 10. Well, the factored form would be x minus 2 and x plus 10, right? Well, that means, another way to think of that, let me say that means, another way to think of it is to say x minus 2 and then x minus a negative 10. So every single time, it's always x minus the root. If the root happens to be negative, then it becomes positive. Okay? And that's important because when you're dealing with something like 3 minus 2i, then you actually need to say x minus, we've got 3 minus 2i, x minus, if 3 minus 2i is there, so it's 3 plus 2i, and then x minus 5. Okay? If you were to distribute this negative, you would find that you actually end up with x minus 3 plus 2i and x minus 3 minus 2i, and then x minus 5. Now, because this happens that you just, you say x minus and the 3 changes sign, but then you have a plus 2i and a minus 2i, you don't need to write this step. You can just go ahead and write it as that, and then we'll do that from here on out. Okay. So now you need to multiply it out, because what I want is I want the function in standard form, not factor form, and that's what we're in right now. Now, a bad idea would be to multiply these two together. It's a bad idea because this one and this one will not have terms that simplify. But if you multiply these two out, you will no longer have any imaginary terms. So we'll just distribute x times x is x squared, x times negative 3, and x times negative 2i. So negative 2ix, negative 2xi, negative xi2, doesn't really matter. Okay. Then we're going to distribute a negative 3. So negative 3 times x is a negative 3x. Negative 3 times negative 3 is a positive 9. I don't have another term like that, so I'm going to put plus 9. And negative 3 times negative 2i is a positive 6i, and that one has an x, so I'll put it over there. Then we're going to distribute the 2i. So if you multiply 2i times x, you get a plus 2ix, which means those cancel each other out. 2i times negative 3 is a negative 6i, so those cancel each other out. And 2i times negative 2i is a negative 4i squared. And if you don't remember what I squared is, let's take a second. The square root of negative 7 is the same thing as saying the square root of negative 1 times 7, or the square root of negative 1 times the square root of 7. The square root of negative 1 is what creates the I, and then that is just the square root of 7. So if I is the square root of negative 1, then that means I squared is just negative 1. Okay? So anytime you have an I squared, that just changes the sign. So that means if that's a negative 1, then negative 4 times negative 1 is a positive 4. So that is x squared minus 6x plus 13. Okay? But don't forget, that was just these two. So now I have to remember to multiply by x minus 5. Okay? So let's start distributing. I always like to distribute the smaller number of terms to the larger number of terms, so I'm going to distribute this one. X times x squared is x cubed. X times negative 6x is negative 6x squared, and x times 13 is 13x. And then negative 5. Negative 5 times x squared is negative 5x squared. Negative 5 times negative 6x is positive 30x. And negative 5 times 13, well, negative 5, or 5 times 10 is 50, 5 times 3 is 15, so negative 65, 50 plus 15. So your final answer is the function, so we need to write f of x equals x cubed minus 11x squared plus 43x minus 65. Okay? Alright, let us move on to the next one. Okay. Yeah, that's fine. Okay, so you've got the roots 1 plus I, the square root of 2, and negative 3. So if I were to determine the degree of this polynomial, I would say 1, 2, because it's conjugate pair, 3, 4, because of its conjugate pair, and then 5. That's just one of them. So I'm going to go ahead and write f of x equals, okay? Like I said, it's always x minus the root. And since it's a positive one, we just leave it as minus 1, and then we're going to put plus I, and then x minus 1 minus I. There's always those two, so I might as well just, it doesn't matter what order you write them in. Okay, I've got square root of 2, so minus the square root of 2, but if there's 1, there's another one, so x plus the square root of 2. And then the negative 3, I'm just going to write x plus 3. And so we start multiplying. So I've got, distribute the x's, or the x first. X times x is x squared. X times negative 1 is negative x, and x times negative I is negative xi. Okay, I'm going to distribute the negative 1. Negative 1 times x is a negative x. Negative 1 times negative 1 is a positive 1. And negative 1 times negative I is a positive I. And then I times x is a positive xi. I times negative 1 is a negative I. And I times negative I times a negative I is a negative I squared. And if I squared is negative 1, that's a negative negative 1, which is a positive 1. So that is x squared minus 2x plus 2 times, well, if I multiply these two out, they're conjugate pairs, and when you multiply conjugate pairs, the middle terms will always cancel out. I've got x squared, I've got plus the square root of 2x, minus the square root of 2x, and minus the square root of 2 times the square root of 2 is the square root of 4, so it's a negative 2. Okay? Middle terms always cancel out, so when you're multiplying conjugate pairs, you might as well just multiply the first two and the last two, because otherwise the middle terms will go away. So this is x squared minus 2, and then don't forget to bring down the x plus 3. Okay? So now we need to multiply it all together. As an intermediate step, what I'm going to do is I'm going to multiply these two. Okay? So I'm going to multiply that times that, and I get x cubed plus 3x squared minus 2x minus 6. And multiply that times x squared minus 2x plus 2. And then I'm going to start distributing. So x squared times x cubed is x to the 5th. X squared times 3x squared is 3x to the 4th. X squared times negative 2x is negative 2x cubed. X squared times negative 6 is a negative 6x squared. Negative 2x, we're going to distribute next. Negative 2x times x cubed is a negative 2x to the 4th. Negative 2x times 3x squared is a negative 6x cubed. Negative 2x times negative 2x is a positive 4x squared. Negative 2x times negative 6 is a positive 12x. And then we're going to distribute the positive 2. 2 times x cubed is a positive 2x cubed. 2 times 3x squared is a positive 6x squared. 2 times negative 2x is a negative 4x. And 2 times negative 6 is a negative 12. Combine like terms, and you've got your polynomial. F of x equals x to the 5th. 3 minus 2 is 1. Now, you could say negative 2 and negative 6 is negative 8, and negative 8 plus 2 is a negative 6, but you might notice that these two cancel each other out. That is pure coincidence, and it happens again here, but it usually doesn't happen. So this is a negative 6x cubed. Those two cancel each other out, and I'm left with a positive 4x squared. 12 minus 4 is 8, and then minus 12. And that is your answer, the polynomial with those roots. Okay? So now we have this. When you start off with a problem like this, you need to remember okay. So you need to remember to figure out how many roots you have and remember to put them in order. So you don't want to put this one next to this one and then have the other one of that one. Okay, so you want to put them beside each other. So f of x equals. I'm going to go ahead and change this up from the one in the notes just because it'll help you a little bit. And since you're not here to ask questions, some of you, then I'll go ahead and change that. So I want to make that a 3 square roots of 2. So that's 1 plus 3 square roots of 2. And actually, let's make that a negative 1. Okay. So we're actually starting with 2i, negative 1 plus 3 square roots of 2, and 3. So for 2i, we're going to have x plus 2i and x minus 2i. For this one, I'm going to write, it's always x minus the root, but it's already a negative 1, so it's going to be plus 1 plus 3 square roots of 2, and x minus, but it's already a negative 1, plus 1 minus 3 square roots of 2. And then for that one, for the 3, we've got x minus 3. Okay? So let's start multiplying. For the first two, when you multiply that out, they're conjugate pairs, so you really only need to multiply x times x and 2i times negative 2i, because the other terms will go away. So we've got x squared minus 2ix plus 2ix goes away, and then negative 2i times a positive 2i is a negative 4i squared, which is a positive 4. Okay? So that is x squared plus 4. I'm going to go ahead and I'll write in a second. On this one, we're going to distribute these two. So I've got x times x, I've got x times 1, and I've got x times a negative 3 square roots of 2. So negative 3 square roots of 2x. Okay? I'm going to distribute the 1 next. So I've got 1 times x, 1 times 1, and 1 times negative 3 square roots of 2. And then we've got the 3 square roots of 2. So 3 square roots of 2x is a positive 3 square roots of 2x, which cancels out. 3 square roots of 2x, 3 square roots of 2 times 1 is a positive 3 square roots of 2, which cancels out. And then I've got a positive 3 square roots of 2 times a negative 3 square roots of 2, right here, that one times that one. Well, I would multiply the coefficients 3 and negative 3. Well, numbers in front of the radicals. So I've got negative 9 times square root of 2 times square root of 2, which is square root of 4, which is 2, and that gives me a negative 18. So that would be minus 18. And I put it in there because I can combine it with that. So that ends up with x squared plus 2x minus 17. And then for the last one I have x minus 3. Okay, now I'm actually going to write, well, no, it's fine. Okay, when you're multiplying these three together, you can choose what you multiply together first. I'm going to choose to multiply these two times each other, and then multiply its answer by that. Okay? So, if I were to think of it as x squared plus 4 times x minus 3, then that would be x cubed minus 3x squared plus 4x and minus 12. And that would be that times that. So I'm still left with my x squared plus 2x minus 17. Okay, so now we start multiplying those. So I usually distribute the smaller polynomial to the larger. It doesn't really matter there. You could distribute 4, I'd rather distribute 3. But it doesn't matter, you're going to have the same number terms. So x squared times x cubed is x to the 5th. X squared times negative 3x squared is negative 3x to the 4th. X squared times 4x is a 4x cubed. X squared times negative 12 is a negative 12x squared. 2x times all those. So 2x times x cubed is a positive 2x to the 4th. 2x times a negative 3x squared is a negative 6x cubed. 2x times 4x is 8x squared. 2x times negative 12 is a negative 24x. And then I'm going to distribute the negative 17. Negative 17 times x cubed is a negative 17x cubed. Negative 17 times a negative 3x squared, let's see, it's 30 and 21, so 51 x squared. Negative 17 times 4x, so 3 was 51, so 4 would be 68. So a negative 68x and 17 times 12. Oh, I'm just going to go. And I get a positive 204. Okay. And if I made a mistake, well, if you catch a mistake, then just fix it, because you know what it should be. Okay. So f of x equals x to the 5th. Negative 3 plus 2 is a negative 1. I've got a negative, let's see, that's a negative 2 together, so that would make that negative 19 x cubed. 51, let's see, negative 12 and 8 is a negative 4, so 51 minus 4 is 47. So just add those up, that's 80, 92, so negative 92x and a positive 204. And there's my equation. So you might have noticed that these are a lot of work. They're not necessarily difficult, but they are a lot of work for sure. Okay? So last one. If I tell you the roots are 4i, then negative square root of 5, and negative 2 with a multiplicity of 2, then your factored form would be f of x equals, if it's 4i, then we're going to write x minus 4i and x plus 4i, the conjugate pair. For the square root of 5, I'm going to write x plus the square root of 5 and x minus the square root of 5. And the order does not matter on those. And then for negative 2 with a multiplicity of 2, I'm actually going to write x plus 2 twice. Now you might think about writing x plus 2 quantity squared, but I caution you against that, because some people do that and then they distribute the square and say x squared plus 4, but if you were to set that equal to 0 and solve, you would get x equals plus and minus 2i, which is not what it's supposed to be. It's supposed to be just negative 2. Okay? So don't distribute the square. You gotta multiply them out. Okay. So I'm gonna multiply these two out, they're conjugate pairs, so I think x squared plus 4ix minus 4x cancels out, so I've got a negative 4i times a positive 4i, which is a negative 16i squared. and a negative 16i squared is a positive 16. I have these two times each other, so x squared. A negative square root of 5x and a positive square root of 5x cancel each other out, so I'm just left with square root of 5 times negative square root of 5, which is a negative square root of 25, which is 5. And then x plus 2 times x plus 2 is x squared, plus 2x is plus 4x, and plus 4. Okay? Now we need to multiply. I'm going to multiply these two first. So I've got x squared times x squared, which is x to the 4th. X squared times negative 5, which is a negative 5x squared. 16 times x squared is a positive 16x squared. And 16 times negative 5 is negative 80. And if I combine those, I've got x to the 4th plus 11x squared minus 80 times x squared plus 4x plus 4. And then we need to multiply those out. So, and they're both trinomials, so I might as well just, it doesn't really matter how I do it. So x to the 4th times x squared is x to the 6th. X to the 4th times 4x is a positive 4x to the 5th. And x to the 4th times 4 is 4x to the 4th. Next I'm going to multiply the 11x squared. So 11x squared times x squared is 11x to the 4th. 11x squared times 4x is 44x cubed. And 11x squared times 4 is 44x squared. And then I'm going to distribute that negative 80. So negative 80 times x squared is a negative 80x squared. Negative 80 times 4x is a negative 320x. And a negative 80 times a positive 4 is a negative 320. So just combine their terms. F of x equals x to the 6th plus 4x to the 5th plus 15x to the 4th plus 44x cubed minus 36x squared minus 320x minus 320. And that is your final answer. Yeah. Okay. So that is how you find a function given its complex roots, be they real, imaginary, or irrational. Okay? Well, real includes irrational. So rational, irrational, or imaginary. Okay.